Hello students, I hope you all are fine. As you know that yesterday we have started chemical properties of alkane. In that we have already discussed about one chemical reaction, that is the substitution reaction. So today we will discuss some more chemical properties of alkane. Second one is the combustion. Combustion. Combustion means burn in presence of oxygen. Burn in presence of oxygen. Oxygen, or we can say air. Or we can say air. Okay. If any compound burn in presence of oxygen or air and it produce heat, then it is known as the combustible. Then it is known as the combustible product. Clear or not? Here we are discussing about the alkane. So students, if we have any alkane, and if it is burned in presence of the oxygen, then it, it will produce carbon dioxide gas plus water plus huge amount of heat energy. Like students, already I told you, LPG constituent particles are propane and butane. Propane and butane. When we burn in presence of oxygen, okay, then what will happen? Some CO2 will produce there, and heat energy also, production of heat energy also produced there. That's why because alkanes after combustion produce huge amount of the heat energy. That's why we use them as fuels. Okay, so generally you should know alkane heated in presence of oxygen, they produce CO2, H2O and heat. Okay, it will depend on the alkane, what type of alkane we are using. Like some produce more amount of CO2, some produce less amount. So we can balance the reactions. Let us consider we have any alkane, CN. Alkanes means which have formula CnH2n plus 2. Okay, they burn in presence of oxygen. When we will balance the reaction, then simply we get this amount of oxygen, means in balancing form. Okay, products will be same in case of all alkanes. If we are burning methane, then we get CO2, H2O and heat energy. If ethane, propane, butane, any alkane, combustion of any alkane if take place, then in all cases we will get CO2, H2O and heat. Clear? But amount, their concentration will depend on nature of the alkane. Clear? Then students, carbon dioxide plus water plus heat. So here N plus 1 mole of H2O. N plus 1 mole of H2O we will get. Because according to law of conservation of mass, reaction should be balanced. Okay, so these are showing the number of moles. For example, if we have methane, one alkane it burn in presence of oxygen, it one in presence of oxygen, it will give just carbon dioxide. Carbon dioxide plus water, because alkane gives us carbon dioxide plus water plus heat energy. Plus heat energy. So how many moles we are using, how many moles of CO2 and water we are getting? Simply CnH2n plus 2. Alkane 1 by 2 oxygen and CO2 n plus 1 H2O plus heat plus heat. Like here NH1. So we will get how many O2 we will consume? 3 into 1, 3 plus 1, 4, 4 by 2. 2 mole of oxygen gas. 2 mole of oxygen gas. Here N is 1, so 1 mole of CO2 we will get. N plus 1, 2. Now it is balanced. Now it is balanced. You can see one carbon and one carbon here. Here 4 hydrogen. Here 2 to ja 4 hydrogen. Here 2 to ja 4 oxygen. Here 2 and 2 for oxygen. Okay. If you are having propane like C3H8. Okay, or open structure you can write CH3, CH2, CH3. Then oxygen, you will get CO2 plus H2O plus heat. In all products will be same. Only concentration will different. Here 3 carbons. 3 carbons, so 3 3s are 9. 9 plus 1, 10. 10 by 2, 5. Clear? Then N. N is 3 and N plus 1, 4. Now it is balanced. So here 3 carbon, here also 3 carbon. Here 8 hydrogen, here 4 to ja 8 hydrogen. And here 5 to ja 10 and here 3 to ja 6 and 4. 10. Okay. It means when 1 mole of propane is heated in presence of oxygen, how many moles we will use? 5 moles of oxygen gas. 5 moles of oxygen gas. Then we will get 3 moles of carbon dioxide, 4 moles of water plus heat. This heat will also vary. This heat will also vary. Clear or not? So students, we get carbon dioxide, water plus heat. Because we are getting heat during combustion of alkane, that's why we use them as fuels. Clear or not? But if incomplete combustion take place, incomplete combustions, maybe oxygen supply we are not doing insufficient amount. Okay. If incomplete combustion we are doing, then we do not get carbon dioxide. Then we get carbon, coke only. Then we get coke only. If we have methane, but we are doing incomplete combustion. Incomplete combustion. Then what will happen? It gives us coke plus water plus some amount of heat also. It gives us coke, carbon black. आपने कई बार देखा है जब हम वुड को, किसी लकड़ी को बर्न करते हैं ऑक्सीजन के प्रेजेंस में, ओके, बट हमारी लकड़ी या तो गीली है या फिर हमने किसी ओपन जगह को ना चूज करके कोई हमने एक मतलब क्लोज प्लेस को चूज किया है, तो वहां पर ऑक्सीजन का लेवल इतना अच्छा नहीं हो पाता, जिससे क्या होता है हमारी जो वॉल्स हैं, जो दीवारें हैं, वो क्या होती हैं, ब्लैक हो जाती है ना। तो वो किसकी वजह से हुई? ड्यू टू इनकम्प्लीट कंबस्शन, ड्यू टू इनकम्प्लीट कंबस्शन। क्लियर? मीन्स जो सफिशिएंट अमाउंट हमें चाहिए ऑक्सीजन का, अगर वो हमारे फ्यूल को नहीं मिल पाता, एल्केन को अगर वो नहीं मिल पाएगा, तो हमें क्या मिलेगा? कार्बन ब्लैक मिलेगा, कार्बन डाइऑक्साइड नहीं मिलेगी। और इस कार्बन ब्लैक को हम क्या, भाई हमने इंक वगैरह अगर बनानी है, ओके, अदर पेंट्स वगैरह अगर हमने बनाने हैं, सो वी यूज दिस कार्बन ब्लैक फॉर दैट। क्लियर और नॉट? यस। Then students, it depends on condition also. It depends on condition also. Means we can do controlled oxidation also, controlled combustion, or we can say control oxidation. Like if we have methane, if we have methane and we heat this and we do combustion in presence of copper, in presence of copper, it is heated at 523 Kelvin, it is heated at 523 Kelvin. Then we do not get carbon dioxide, water, heat, then we get methanol. Methanol means if we change conditions, so we can control reaction also, and we can divert our product also. Like here methane and oxygen, you all know very well, after combustion it gives us carbon dioxide, water and heat. But here we change catalyst. By using catalyst we are getting methanol. Here addition of oxygen take place to this one, addition of oxygen, and addition of oxygen is known as the oxidation. Okay, so we controlled the reaction in presence of catalyst, okay, and we found the product methanol after oxidation. Clear? Then if it is heated in presence of molybdenum oxide, molybdenum oxide, then we get methanol. Methanol, this is methanol, this is methanol. Methanol मीन्स हमारी कंडीशंस पर भी प्रोडक्ट्स जो हैं हमारे वो डिपेंड करेंगे। अगर हमने मोलिब्डेनम ऑक्साइड के प्रेजेंस में हीट किया है मीथेन एंड ऑक्सीजन को, तो फिर हमें क्या मिलेगा? मिथेनॉल। ओके, सो स्टूडेंट्स, if you do simple combustion, then you get CO2 plus H2O plus heat. What does it means? It means our product will depend on conditions. Under which situation, under which condition we are proceeding the reaction, product will depend on that. Then if it is given complete the reactions, complete the reaction. In all reactants are same, CH4 plus O2, CH4 plus O2, CH4 plus O2. But you are changing these conditions only. If you are changing these conditions, then your products are also varying. Okay, so you need to see this one. Clear or not? Yes. Next one is the isomerization reaction. Isomerization. Isomerization means conversion of one isomer to another isomer. One isomer to another isomer. Let us consider we are having hexane. Hexane. And if we heat this in presence of anhydrous AlCl3 plus HCl plus HCl, then we can get different isomers for that. Like we can get 2-methyl pentane, 2-methyl pentane, 3-methyl pentane, 2,2-dimethyl butane. Means isomerization reaction in which one isomer can be converted into other. If you have hexane, means 6 carbons, 6 carbons you are having. If you heat this in presence of anhydrous AlCl3 plus HCl, because anhydrous AlCl3, it is Lewis acid, it need electron. For getting electron, it will break bond of this one. Clear? If it will break bonds, then new bonds will form. Then one isomer can be converted into other. Clear or not? So it may be happen 5 carbons in chain, but 1 carbon in branch. क्लियर मीन्स जो इधर कार्बन टू कार्बन बॉन्ड है वो इधर से ब्रेक होकर हमारा कहीं बीच में अटैच हो सकता है, एक आइसोमर दूसरे आइसोमर में चेंज हो जाएगा. मीन्स CH3 CH2 CH2 CH CH3 CH3 isomer mean which have same molecular formula, but different structure only. Okay, here 6 carbon, 3 5 7 9 11 14, 14 hydrogen. Here also 1 2 3 4 5 6, 6 carbon, 3 5 7 8 11 and 14 hydrogens. Others maybe this new carbon can be attached to this one also. You can get other like 2,2-dimethyl. Only some we are writing here. Butane, 2,2-dimethyl. Butane, 1 2 3 4 5 6, 3 6 9 11 and 14. Okay, so isomerization reaction means in which one isomer convert into another isomer. Okay, so if we heat one alkane in presence of the anhydrous AlCl3 aluminum chloride and hydrogen chloride, then it can convert into different isomers. Maximum isomers you can write, but in organic chemistry we deals with the major product. Okay, that's why we are writing only 2 or 3, otherwise you can write maximum. Clear or not? Yes. Next one reaction is the aromatization reaction. Aromatization reactions. Aromatization means alkane is aliphatic. After applying some conditions, we can convert this into arene. Arene means benzene or benzene compounds, benzene or derivatives of benzene. Derivatives of benzene. And arene is the aromatic. Means aliphatic alkane can be converted into the aromatic after applying some conditions, and that type of reaction is known as the aromatization reaction. Like students, if you have 6 carbons or more than 6 carbons, 6 carbons or more than 6 carbons, if you heat at 773 Kelvin temperature, if you have hexane, why we are taking minimum 6 carbons? Because in arene, in benzene, there are 6 carbons. Okay, so at least 6 carbons should be there. If you are having n-hexane, and you are heating it at 773 Kelvin, and you are applying pressure 10 atmosphere to 20 atmosphere, and you are doing this reaction in presence of catalyst Cr2 O3 or vanadium pentoxide, V2O5, vanadium pentoxide. Then what will happen, students? Here dehydrogenation take place. Here dehydrogenation take place. Hydrogen removal take place. And we get benzene. We get benzene. Like, I can write this one, CH3, CH2, 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 1, 2, 3, 4, CH2, CH3. I can write this n-hexane in this way. Okay. Then in these conditions, aromatization take place. What will happen? This bond between carbon and hydrogen will break. Bond. What is the benzene? This is benzene. What will happen? Here bond between carbon and hydrogen will break, and this bond between carbon and carbon will form. Okay. Here its formula is C6H14. C6H14. But it is C6H6 only. C6H6 only. What is happening? Hydrogens are getting removed. Okay, so here removal of hydrogen taking place. That's why it is also known as the dehydrogenation, or here aliphatic alkane converting into aromatic hydrocarbon. That's why it is known as the aromatization. But if you are having 7 carbon, like this CH3, CH2, 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 CH3. I'm writing in this way. Okay. 1, 2, 3, 4, 5, 6, 7. Same conditions you will apply. Same conditions you will apply. Then same thing, aromatization take place. Means in 6 you are getting benzene, but one extra carbon is here. This methyl, here toluene, methyl benzene, methyl benzene or toluene. Means if you have more than 6 carbons, then you can get derivatives. Then you can get derivatives. If you are having 8 carbons, 8, then you can get 6 and CH2, CH3, ethyl benzene. Clear or not? Yes. Means minimum 6 carbons should be there. In 6 you will get benzene, and more than 6 you will get derivatives. You will get derivatives of the benzenes. Okay. So today we have discussed about some chemical properties. Some chemical properties of the alkane. Our chemical properties was combustion, isomerization, and aromatization. Any doubt in any of the reaction? Okay. So students, 2 more reactions are there. We will discuss about them tomorrow. Any doubt in this? So thank you. Have a nice day. बेल किस टाइम होती है?